Hi, I'm David from the RACOM product management team, and today I'm here to tell you all you need to know about microwave antenna alignment. Let me start with a bit of theory. Microwave links are a key component of wireless communication systems. They use high-frequency radio waves to transmit data between 2 points, often over long distances. These links, like our RAY3 product family, are commonly used for telecommunications, backhaul connections, and even for providing internet access in remote areas. Microwave links operate on a principle called line of sight. This means that the antennas at both ends of the link must have a direct, unobstructed view of each other. Think of it like shining a flashlight from one point to another. If there is something blocking the light, the signal won't get through. Similarly, obstacles like buildings, hills, or trees can disrupt the microwave signal, so ensuring clear line of sight is crucial. RAY3, thanks to its excellent sensitivity, can even operate a near non-line of sight condition, but sacrificing a lot of capacity. Fresnel zones, also known as Fresnel ellipsoids, are important in microwave and radio wave propagation. They describe the three-dimensional areas around the direct line-of-sight path between transmitting and receiving antennas. Each Fresnel zone is shaped like an elliptical volume that extends along the path between the antennas. The size and shape of these zones depend on the wavelength of the signal and the distance between the antennas. The first Fresnel zone is the most critical for line-of-sight communication. It should ideally be mostly clear of obstructions. If any object, such as a building or a tree, intersects the zone, it can cause signal interference and reduce signal quality. The size of the Fresnel zones can be calculated using mathematical formulas that take into account the frequency and the distance between the antennas. You can easily calculate it using our web calculator or RayTools mobile app. Proper antenna alignment ensures the best possible performance of the link. The complication is that antennas do not radiate signal in one single direction, but instead generate something called main and side lobes. The main lobe is the primary central region of the antenna's radiation pattern, where the majority of radiated energy is concentrated. It is the most important part of the radiation pattern, as it represents the intended direction in which the antenna is transmitting or receiving signals. Side lobes are secondary radiation lobes that exist alongside the main lobe. These lobes represent areas of the antenna's radiation pattern where some energy is radiated, but not as much as in the main lobe. As you can see in the picture, 3D radiation diagrams are quite complicated, but our 2D simplification is quite okay for practical purposes. When aligning antennas, ensuring that the main lobes of both sides of the link are pointed at each other is crucial for optimal signal reception or transmission. A well-aligned main lobe leads to strong signal and reliable communication. In case you align onto a side lobe, your link will be unstable, unreliable, and prone to interference. Always make sure you have found the main lobe on both sides of the link. Practical way to check your alignment result is to make a calculation using our RayTools app and compare RSS. If your real-life signal strength is similar to the calculation, your link is well aligned. On such a link, you can expect differences ranging from +1 to -2 dBm. In case the difference is 15 to 20 dBm, you are aligned to a side lobe and need to realign the link. Let's use this knowledge to align a RAY324 link. Before alignment, always make sure to use a narrow channel, low modulation, and high power where possible. Such a setting makes it the easiest to catch the signal from the other side. Also, ATPC and ACM or ACMB functions should be switched off, since they may cause RF output power fluctuation during alignment. Today, I'm here on the roof of RACOM HQ with Michal from our engineering technical support team. Thank you, Michal. Link alignment is usually done with two teams, one for each side of the link. The teams take turns in alignment. In case of bad weather, it is best practice to align in the direction of the farthest visible object in the correct direction. Please note that metal poles and grounding cause compass interference. Binoculars and a visual search are the way to go in most situations. First step is to roughly align the link so it connects and we can start measuring signal strength, or RSS. This particular link uses the Euro's 30-inch antenna with its well-designed mount. There are two screws on the mount, one for horizontal and the second for vertical movement. Please note, they may be located differently on your device, but they are always there. We will keep Ray tools open on the screen in real time for you, so you can see what is going on. Michal fixes the vertical screw roughly in the right direction and loosens the horizontal one completely. Then, he turns the antenna by hand to find the signal to get an approximate direction. When he finds the signal, he tightens the horizontal screw. The same procedure is done by our second team on the far side of the link, and they go right ahead and start fine alignment. We wait for them to finish and start fine alignment on our side. Michal recommends doing horizontal alignment first. He starts to slowly turn the horizontal screw, listening to sound output from his Ray Tools app. He is looking for the main lobe, knowing his vertical alignment may be a little off. As you can see on the RSS plot, Michal finds a side lobe. Then something that could be a main lobe, but to make sure he continues. Only after finding another side lobe, Michal knows he was at the right spot before, so he goes back. There are three possible scenarios he may encounter, shown on a plot like the one you may see in Ray Tools app. He may hit the main lobe, which is the best scenario. He may hit the side lobe 2 times, knowing he needs to leave the antenna somewhere in the middle. Or he may hit the side of one of the side lobes, which is also okay for this moment. In case of really long links and signal fluctuations caused by weather or wind, it can be difficult to pinpoint the main lobe maximum. There is a trick to help you, in which we use the steepness of the main lobe and count the amount of turns on the screw from start of the main lobe to the end. Then we go back exactly half the turns to get to the peak. Now he switches to the vertical screw, starting down, because going up the antenna works as a counterweight. Scenarios are similar to horizontal alignment, but since we should be getting close, he's also looking at the RSS value, comparing it to the calculation. Last step is to fine align the horizontal direction again, making sure we get as close to the theoretical RSS value as possible. In case we did not reach the calculated value, we would repeat the process. Here are a few scenarios that can help you troubleshoot. 15 to 20 dB difference indicates link uses side lobe instead of the main one, and you should try to align again. 25 to 30 dB points to polarization mismatch, and one radio needs to turn 90 degrees. In case this does not help, you should inspect the waveguide to check it's clear. Check the antenna frequency or any damage to the unit, waveguide or the antenna. Since our match, we know we don't have to. And that is all. Thank you, Michal, for the expert demonstration, and to you all for watching. In case you have any questions, please feel free to ask them here in the comments or contact Michal and his colleagues from our technical support. We also have a full Ray 3 installation video here on YouTube, in case you're interested. Thank you for watching and have a great day.